Alright, so let's bring this rollicking, rip-snorting, week-long adventure into powers and their index laws behind them to an end. There are 6 of them you've got to learn. We've done 4 of them so far this week. We're going to do the last 2 today and get through them. So where we are so far is you've learned how to do all this stuff. You've learned how timesing, dividing, and brackets can make powers do different things. So as a reminder, right, with our variables, with our bases, with their powers. When we've got a times in between, we just add the powers together. So really, when you're working with powers, you should just be asking the question, how many of this letter, how many of that letter, and just put them together through adding, taking, or timesing. So in this question, there are 8 lots of A because there's 5 of them plus 3 more of them. Look at all those A's together. B, there's going to be 7 of them. That's because we add the powers together. With this 2, with this 4, they're not powers, right? They're numbers. They're at the front. So if you've just been given 2 numbers and you're asked to times them together, just do what you do with numbers, times them together, right? So the coefficient out the front will be number 8, right? We times the numbers, but we add the powers. Same thing here, right? We've got a divided by sign. I've got numbers out the front. These aren't powers, they're numbers, so just divide them. 4 divided by 2 is 2, and then we're just getting rid of powers, or subtracting them, following index law 2. So I had A7, I divide A1, right? There's a 1 there on that one. We just don't bother writing it. Gives me A6, and then 3 lots of B, take away 2 lots of B, leaves me with 1. Then with our brackets, we learned that we should multiply the powers together. So the 3 on the outside is what you're multiplying every power on the inside. So the A gets a 6, B gets a 9, and then we have to remember, again, this is a number, it's not a power, so you actually need to put the power of 3 on the 2, right? This is 2 to the power of 3, it's 2 times 2 times 2, so that ends up turning it into 8. And that's what we've practiced so far. We're going to learn some more index laws now, which are a little bit different, a little bit more random. So our lesson today is dealing with kind of special powers. It's not just normal powers being times, divided, or bracketed. You might have noticed a clue on the title slide. We're dealing, for a start, with the number 0. Okay, so the number 0 is kind of viewed as a special power, I guess, when we teach this maths. So we're going to learn about the effect that the power of 0 has on numbers and on letters. So here it is. Put it in your glossary. Pretty straightforward today, short sentence. You just have to know this fact. We won't spend too much time going into why it is the way it is, because we just don't have time on a video like this. You have to know that anything that has a power of 0 on it equals 1. It turns into the number 1. Maybe we'll go over that sometime when we're back in class together. So if you see something with a power of 0 on it, the answer is 1. Okay, so a to the power of 0, 4 to the power of 0. Doesn't matter whether it's a variable or a number. If it has the power of 0, it is 1. Okay, so this is in your glossary alongside all the others. Unfortunately, it's not going to be quite as easy as just writing the number 1 as your answer to everything. The power of 0 will be kind of sprinkled through your maths in different spots. So we've just got to kind of learn when the answer is 1 and when it isn't. So we've got a few different examples here with kind of powers of 0 sprinkled all through it. So your approach should be look at what has the power of 0 on it, turn the thing that has that power of 0 into a 1, and then do any other maths that's around it, or keep anything else that's around it in your answer. So in this question, the A has a power of 0, the 4 doesn't, right? The 4 is in front of the A to the power of 0, and it's kind of multiplying the A to the power of 0. So if I was going to show some working out, I would turn the power of, or the A to the power of 0 into a 1. Right? I'd keep the 4 though, right? It's 4 lots of 1. So this answer just ends up being 4. Now this one here is different. Basically, the entire thing is in brackets. The entire thing has a power of 0 on it. So I could apply my other index laws where I put the 0 on this and the 0 on that, but at the end of the day, the whole thing is just going to turn into a 1. So you can just write 1 for that one. This one is more like the top one, right? I've got an A, it's in brackets, it's got a power of 0. So what I can essentially do is say that this part here is going to turn into a 1, but this part isn't, right? That's still a 4. And it's timesing the brackets, it's timesing that thing there. So it's 4 times 1 again, it's 4. This one here, the 4 doesn't have a power of 0, it's just a 4. Right, these things are all timesing each other as well, right? The A and the B and the C and the 4, they're all multiplying. So we'll just put these in between them all. So the A does have a power of 0, that means it's going to turn into a 1. The B is just a B. All right, it doesn't have a power of 0, so that's going to be kind of part of my answer. And the C has a power of 0, so that turns into a 1. So if I put all of these things together, 4 times 1 is 4, and there's a B there as well, so the whole thing makes 4B. These little ones here, so the entire set of brackets has a power of 0, so let's just turn that whole thing into a 1. And in this case, I can turn all of this into a 1. That's going to go, and then whatever's on the outside stays, so that would just become Joe. All right, plenty of examples for you to think about. So now that we've learned that the power of 0 is just going to turn everything that it touches into the number 1, we can get onto our final index law and get this kind of unit of work over and done with. So index law 6 is again a bit of a special one. It's used when we go from having positive powers to negative powers, and the crux of this lesson, the main message you've got to get is that we don't like negative powers in our maths. It's not simple to work with negative powers. We don't really like the look of them. Negative powers are bad in our working out. So this -4 should fill you with revulsion and disgust and make you just want to vomit all over your screen. It's a normal, natural feeling. You can't get around it, so we've got to learn how to deal with this. So to think about what's going on here, I am just going to kind of show you what's going on with these powers, and you might actually get a clue of why powers of 0 equal 1. What you should remember from your powers is that if I have a 4 with a power of 1, that's just 4, right? It's just a 4. 4 squared means I've got 4 times 4. That's 16, right? And really, when I'm dealing with the base 4 and different powers on it, when I take a step up with a power, I times by 4, because I have another 4 in there now. When I come back this way, I'm really dividing by 4. Okay, so over this side, I'd have like 4 to the power of 3. It would be 64, right? Because I'm timesing by 4 to go that way, or dividing by 4 to come back this way. So what that means is if I'm going to go back even further this way, right, it means I'm dividing by 4 again and again, right? Every time I get a power less, I'm kind of dividing by the base. So 4 divided by 4 is 1, right? And you'll find that always happens no matter what your base is. You get the number 1 here. And then what happens is I need to keep dividing by 4 to go into negative power territory. So 1 divided by 4 is a quarter. Then if I divide by 4 again to go even further into my negative power territory, I have 1 on top of 16. And hopefully what you'll notice is this has a lot in common with that. And this has a lot in common with this one here, right? So 4 to the power of 2 has an awful lot in common to 4 to the power of -2, right? 1 is 16, 1 is 1/16. On the next slide, you'll get your glossary entry. Okay, so what I'm trying to show you here is that when you have a base, we've just used the letter A to represent it. When it has a negative power on it of any kind, we don't like the negative side of it, so we're going to do something. We're going to turn it back into a positive power. And the way to do that is just to put it in a fraction, right? We saw before that 4 squared is 16. So if I have a -2 instead of a 2 on my power, right, this one's 16. So because I know that normally it would be 16 if it was a positive power, I just put the 16 in a fraction. That's essentially what index law 6 is all about. When we are given a negative power, we can rewrite it to simplify it as a positive power by putting it underneath a fraction. Okay, so your examples that go with this are on the next slide. Here's our first one, right? I have an a with a -3. I don't like it. I don't like it being negative, so I rewrite it as a to the power of +3, but I put it in a fraction. Okay, and it's written nicer. You could view negative powers as being divided by as repeated over and over again if you wanted. A power is normally timesing over and over again, so a negative power is dividing over and over again, so put it in a fraction to show that it's divided by. This one here, we don't like -12, so let's just write 12, right? But put it in a fraction, and it's fixed, kind of thing. And for the last one, I've got 2 parts of this. I've got a 2 here and a c with a -222. Again, the negative is the part we don't like. So we rewrite the power to be a positive one, right? It's +222 now. I need to put something on top. These didn't have anything else out the front, so I just put a 1 on top, basic fraction. This has the number 2 on top, so the number 2 at the front, so you put the 2 there. All right, all the parts of the original thing are there. The negative power went on the bottom, and the positive power stayed on top. And that's some advice I'm just going to give to you to answer the harder questions today. Okay, So when you are given a big string of things, they're all going to have their own powers, they're all going to be together but have separate powers. Find anything that has a negative power or a negative index and put it on the bottom of a fraction. And anything that has a positive power, you can just put up top because it's not being divided repeatedly. Okay, so if I get something like this, I have x with a negative power and y with a positive power. I've got to rewrite that negative power as positive. There it is. The y had no problems, so it's on top. Okay, I've got 2, I've got x, I've got y, I've got z. The negative powers go on the bottom, and you can rewrite them so they're not negative anymore. And the positive powers, the 2 and the x, there's no negative powers on them. They stay on top. Okay, same thing again. We'll put the x on top. We'll put the y on top. They have positive powers. They're fine. They can go there. The z has a negative power. Let's make it positive. Put it on the bottom. And 4 squared would normally be 16. 4 times 4 is 16, so we can put that 16 that we get from going 4 times 4 on the bottom. Okay, so that's kind of as hard as the work is that we're going to set you for index law 6. You've got a few questions to do on both of the index laws, the power of 0, turning things into 1, and negative powers, which just become positive by putting them in a fraction. All right, so you've got a few questions to do around that, and then we can move on from index laws to some other algebra next week.